Okay, so we're all getting pretty used to the idea of having a single AI assistant, right? But the next big thing, the real frontier, isn't about just one AI. It's about building entire teams of AIs that work together. And it turns out there's a whole new science to making them work well. So let's dive in and break down the blueprint for building the AI teams of the future.
It kind of feels obvious, doesn't it? If you've got a really tough problem, you just throw more brain power at it. So more AI agents should equal a smarter, better system. But is it really that simple? That's the big question we're going to tackle.
So first up, let's get on the same page about what we're even talking about here, because we have moved way beyond simple chatbots. We are now officially in the era of the AI agent, and their potential is just incredible.
So what exactly is an AI agent? Well, think of it like a brilliant chef in a kitchen. You don't just tell it what to cook. You give it a high-level goal, like, hey, make an amazing 5-course meal. That agent can then reason about what that means, plan the whole menu, find the recipes, and then actually take action. Chop the vegetables, start the oven to make it all happen. It's a system with a goal and the power to act on it. And that brings us right back to our big puzzle. If one AI chef is great, are 5 AI chefs automatically better? For a long time, the common sense answer was, of course. But as we're about to see, that assumption is very, very often wrong.
And this is the key insight from the research paper this is all based on. We've been building these AI teams and putting them to work, but honestly, we've been doing it without a real scientific playbook for why they sometimes succeed and why they sometimes fail spectacularly.
So, to fix that, researchers decided to finally take a proper, systematic, scientific approach to this. They set out to create a real playbook for building AI teams, and they did it by testing them like a coach running drills with every possible team formation to see what actually works.
And let me tell you, they were incredibly thorough. They tested 5 different team structures on 4 totally unique tasks. They ran these tests using 3 different families of AI models. All in all, that created 180 different setups to analyze. This wasn't just some one-off experiment. This was about finding the universal rules of the game.
So what did all that testing actually reveal? Well, the results were amazing. They didn't just get a mountain of data. They discovered 3 clear and frankly pretty surprising rules that seem to govern how all these AI agent teams perform. This is the new playbook.
All right, let's get into it. Rule number 1 is something called the tool coordination trade-off, and it really gets at a fundamental balancing act you have to manage.
Okay, so here's the deal. Giving your AI team more tools, like access to the internet or the ability to run code, can make them way more powerful. But, and this is a huge but, there's a cost. All the time they spend talking to each other, coordinating their actions, you can think of it as the AI equivalent of endless meetings and reply-all emails. That's called coordination overhead, and it can slow the team down so much that it completely cancels out the benefit of having those cool tools in the first place.
Rule number 2 is a really big one, and it might change how you think about teamwork. It's this idea that there's a very real limit to the benefits of collaboration, and it's called the capability saturation point.
The research actually found a kind of magic number here, 45%. It turns out that if a single, powerful AI agent can already solve a problem correctly about 45% of the time all by itself, then adding more agents to the team is basically pointless. At that point, teamwork doesn't help. In fact, performance usually gets worse because of that coordination overhead we just talked about.
Now, this third rule is maybe the most important one to understand, and it's a serious warning. When AI agents work in a team, their mistakes don't just happen. They can either be contained or they can spiral wildly out of control. And it all comes down to how you structure the team. And the data here is, honestly, it's pretty shocking. If you just let a bunch of AI agents work independently, like a free-for-all, a single small mistake can get amplified by over 17 times. It's just chaos. But if you use a centralized team structure with one head chef calling the shots, you contain that damage. The error amplification drops to a much, much more manageable 4.4 times. The team structure is absolutely everything. So, now that we have these 3 rules, what do we do with them? How do we actually build the best team? Well, it's not about finding one perfect structure that works for everything. It's all about picking the right team for the specific job you need done. Okay, this right here is the ultimate cheat sheet from all that research. For what they call parallelizable tasks, things that can be broken up and worked on at the same time, like analyzing a bunch of financial reports, a centralized team is a huge winner. It boosts performance by over 80%. For something like navigating the web, a more flexible, decentralized team works a bit better.
And here's the kicker. For tasks that need step-by-step, sequential reasoning, where step B depends on step A, adding a team is a complete disaster. A single agent is way, way better. Using a team for that can actually crush performance by up to 70%.
So let's just zoom out for a second, because the big takeaway here is this. We are seeing a massive shift. Building powerful AI systems is no longer just guesswork, no longer just trial and error. It's actually becoming a predictable science.
And how predictable are we talking? Well, this new scientific framework can correctly predict the absolute best team strategy for any given task 87% of the time. That is an incredible level of accuracy. It means we can now design these complex AI systems intelligently instead of just crossing our fingers and hoping for the best.
And maybe the most exciting part of this whole thing, these rules don't just work for the AI we have today. The researchers tested their framework on simulations of more powerful next-generation models, and the principles held up perfectly. So this isn't just a snapshot of today. This is a genuine blueprint for the future of AI.
And all of this leaves us with one final, really powerful question. For the very first time, we have a scientific guide for assembling superintelligent AI teams. We know how to make them effective, and we know how to avoid the pitfalls. The only question left is, what monumental problems are we going to point them at first?